Trigonometry is good for finding missing sides and angles of a given triangle using our acronym SOHCAHTOA. However, we can also use trigonometry to figure out the area of a triangle. We're all used to the formula of the area of a triangle being 1/2 the base times the height, something we've seen for many years. Very easy. As long as we have the base and the height, we can figure out the area of a triangle. However, if we're not given that, we can use trigonometry to figure out what the area of the triangle itself is. So the area, in order to use the formula, we need two sides and the included angle. So here we have the three possible variations it could be: 1/2 AB sine C, 1/2 AC sine B, or 1/2 BC sine A, where sine C, sine B, sine A all deal with the angle measurements, and then AB, AC, and BC are the measures of the sides. So when it comes to the triangle, we're used to labeling a triangle with points A, B, and C. These points actually note the angle. So this point right here actually deals with angle A. Here's angle B, and there's angle C. And we use capital letters to note those points. Now, A, B, AC, and BC are lowercase letters, and we use them to note the sides. And the sides are always across from their related angle. So side A is going to be across from angle A. So side A is going to be opposite or across from angle A. Side B is going to be across from angle B, and side C is going to be across from angle C, opposite. So whatever those measures are what we'll use in our given formula to figure out the area of the triangle. And again, the angle has to be included between the two sides. So AB sine 1/2 AB sine C. So there's side A, there's side B. Notice angle C is included between A and B. So that's why we have to say the angle is included. So here in our first problem, we have triangle BAD with side BA is 8, AD is 6, and angle A is 150 degrees. So first thing we should do is draw a triangle and note the points B, A, D. Now it says B to A is 8. And it says from A to D is 6, and angle A is 150 degrees. We can use our above formula, 1/2, in this case, BA times AD times the sine of C. So again, angle A is included between the two sides, so we can use the formula. So in this case, it's going to be area is equal to 1/2 our two sides, so 1/2 times 8 times 6 times the sine of our angle, 150. And all we have to do is plug that into the calculator to figure out what the measurement is. Now again, we're dealing with degrees within a triangle, so we need to make sure that we are in the correct mode. So in my case, I have to go over to degree and hit enter. Once we have it all set, we can go back to our main screen, and we have 1/2 times 8 times 6 times the sine of 150. And we get an area of 12. That one was pretty nice. Gave us a nice solid number. Now we have to find to the nearest 100 the number of square feet in the area of a triangle lot at the intersection of two streets of the angle of intersection 76 degrees, and the frontage along the streets are 220 feet and 156 feet. So here we have two streets, so we want to draw a nice little picture. So we know we have a triangle. We're intersecting. So if the two streets intersect, we know we have an angle of, I'll use 76 degrees. I'm not going to worry about the 10 minutes. So 76 degrees, and the frontage are 220 feet and 156 feet. We need to figure out the area. So again, the angle is in between our two sides, so we can just set up the formula. Area is 1/2 times our two lengths, 156 times 220 times the sine of our angle, sine of 76. And we just have to plug it into our calculator. And it gives us 16,650.27466. So again, to the nearest 100, so ones, tens, hundreds, so 16,650, we'll round up to 16,700. More accurately, according to our problem, it would be 16,650 would be the more accurate area. Here we have the area of a parallelogram being 20. And we need to find the measure of the angles of the parallelogram if the measures of the two adjacent sides are 8 and 5. So parallelogram, here we have our parallelogram. We're told two sides are 8 and 5, and if it's a parallelogram, opposite sides are congruent. So this side is also 8 and that side is also 5. So we need to find the angles of these measurements. So what we can do is actually split it up into two. So if we cut it into half, we know the area of each triangle, in this case, is going to be 10. So because we know our final answer, we can find this angle. This angle is our unknown. So what we want to do is use our formula. Area equals 1/2 AB sine C. And we can figure out this angle. And once we know this angle, we can figure out the other angle. So we're just going to plug in the numbers that we know. So if we split it in half, we knew the area would be half of the parallelogram. So in our case, we're going to be dealing with 10 is equal to 1/2 our two sides of the triangle. So 1/2 times 8 times 5 times the sine of our angle, which we don't know at this point. So what we'll do is we'll do the multiplication that we can. So we have 10 equals 1/2 times 8, half of 8 is 4, times 5 gives me 20, sine C. And here we'll divide by 20. And we end up with 1/2 being sine of C. So now to figure out what the angle is, we have to use the arc sine. So the arc sine, again, is the sine with the exponent of -1. So the sine -1 of our ratio, 1/2, is going to be what our angle is. So that's going to be our angle. So what we want to do is arc sine of 1/2. So that tells me the angle is 30 degrees. So we can say this is 30 degrees here. And in a parallelogram, we know that the consecutive angles are supplementary, meaning they add to 180 degrees. So we know the other angle, x plus 30, is going to give me 180 degrees. Which means if we subtract 30 from both sides, we get our other angle to be 150. So the two angles that would be in our parallelogram are 150 and 30 degrees each. Now we need to find the exact value of the area of an equilateral triangle if the measure of one side is 4. So equilateral triangle means all three sides are the same. So if one side is 4, that means all sides are 4. And the other thing about the equilateral triangles is if all the sides are the same, all the angles are the same. And in a triangle, all angles add up to 180 degrees. So if I split that into 3, it means each angle is 60 degrees. So the exact value, if we use the sine formula, would be 1/2 of our two sides, 4 times 4, times the sine of 60. So all we have to do is 1/2 times 4 times 4 times the sine of 60. And we get 6.9282033. So anytime we're dealing with trig, we tend to round after 4 decimals. So 92820. So our area is going to be 6.9282. And that would be the exact value that we use. So here we have a farmer planning how to divide his land for planting next year's crops. He's got a triangular plot of land and left with 2 known sides measuring 500 and 1700 meters. So what could he do to find out the area of the plot? Well, first things first, it's a very lengthy process, so I'm not going to do it, but you would find the height, and then you would use base time, 1/2 base times height. The other thing he could do is figure out the angle measurements between the two sides and figure out what the exact area is using the sine. But it's a lengthy process and you don't really have to worry about that. Real estate developer in this problem searching for the next piece of land to build on. He sees a plot of land in the shape of triangle ABC. Real estate developer measures lengths of AB and AC, finds them to be approximately 4,000 feet, and has an included angle of about 50 degrees. So what we need to do is draw the picture, label everything, and then find the area of the piece of land. So we got this triangular piece of land, ABC. And A to B and A to C are both about 4,000 feet. So 4,000 and 4,000. And the included angle, so the angle between the two sides, is about 50 degrees. So there is our diagram. What we need to do now is find the area. And again, as long as I know two sides and the included angle, I can use the formula using sine. So area is going to be 1/2 our two sides, 4,000 times 4,000. And then we have to multiply it times the sine of our angles, 50. And again, we just plug it in, 1/2 times 4,000 times 4,000 times the sine of 50. And we get an area of 6,128,355.545. So that is a nice big plot of land. 612,8355.545. And again, they gave us a unit of measurement, so it'd be square feet in our case. So that is using sine in order to find area of a triangle. Again, we need the two sides and the included angle in order to use it. Otherwise, we have to use 1/2 base times height as long as we have the base of the triangle and the height.